All right, let's continue with 10.3. 10.3 dealt with permutations and combinations. So it's still counting, it's still chapter 10, counting problems, but you just have to have the difference between when do you use this and when do you use that. You need to be sure you know how to find those buttons on your calculator, and you need to know which one to use when. So looking at 39, we're trying to elect officers of a club. How many ways can a president and vice president be determined in a club with 12 members? So there's 2 offices. Okay, there's 12 people. So we know we're going to choose 2 from the 12. And because of a president and a vice president, order matters. So, darn it, order matters. And so we're going to use a P for that. Okay, when order matters. So first, second, third, president, vice president, treasurer, that's P. Okay. And on the C, that's when you're just selecting people to be on a committee, but it's like they are of equal level. Okay, where order really doesn't matter. Okay. So on 40, first, second, third prizes are to be awarded to 3 different people. There's 10 candidates. We're trying to award 3 prizes. Order matters. It would be 10. And then you would use the P button. I don't have my calculator with me to do that, but you be sure you're using the P when you calculate it. Let me go grab one real quick. Sorry, Mom. Okay. Because you ought to try those and make sure you're using the button correctly. So like 12, choose 2 when I'm doing permutations. Okay, would be 132. And then 10, put in the 10, go to NPR, and then go and pick 3, you get 720. Okay, so that's the idea there. All right, let's go down and look at this one. So here we're picking committees of U.S. senators. How many different 5-member committees could be formed from the 100 U.S. senators? 100 senators choosing 5 to be on a committee. Okay. And so we want to know how many different committees could be formed by the 100 U.S. senators, 5 people on a committee. So we're choosing 5. And it's not like one person of the committee has a higher rank than the other. So that's why it's a C. And if you did that, you would be able to pick a bunch. Okay. So that would be 75,287,520 different committees. All right, card hands are, a classic example because you can rearrange the cards in your hand, so the order doesn't matter; it'd still be the same hand. So you would use C for that. Okay, so you know about the cards. Okay, and there's that many different 5-card hands possible. Decide how many would consist of the following cards. All diamonds. Well, there's 13 diamonds, and if we choose 5, 13 choose 5, there'd be 1,287 cards that would all be diamonds. Okay. All black cards. There's 26 black cards. There's 5 cards. We're trying to make 5-card hands. So 26 choose 5 means there'd be 65,780 hands that are composed of all black cards. We can't make a 5-card hand that's all aces because there's only 4 aces. Okay, so that one's not possible. All right,